Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you back to the course material lecture series of Transportation Engineering 2. In today's lecture, we will be discussing about sleepers. As we have seen, sleeper is one of the component of the railway track. We have already discussed about the another component of the railway track, that is rails, and the associated features with rails like the creep in rails or wear or failures of rails or the joints in the rails. So, in today's lecture we will be discussing about the sleepers, the different types of sleepers, the sleeper density, sleeper spacing. First of all, we will try to look at the different functions which any sleeper will be imparting. Sleepers try to hold the rail sections to correct gauge and alignment. This is on the basis of different fixtures or fixed or fastenings which are used so as to control or keep hold of rail sections. So, this is the very first prime important function of the sleepers. The gauge should be maintained, and as far as possible the alignment should not get distorted. Another aspect is that they should be able to provide firm and even support to the rail sections. The rail sections are being placed at the top, and if they are not being supported, then they are going to sink into the ballast cushion. So, that should not happen. They should have a wider area by which they will keep remained in the floating condition in the ballast cushion medium, and that is how a support system is devised. They should be able to transfer the load to a wider area of ballast. As we have seen, the concentration of loads as we go from the top to the bottom keep on reducing. They are heaviest at the top, and that is why the heaviest sections have been provided as the rail sections. But as we come to the ballast section, the strength capabilities of the ballast section taking the unit area are quite less as compared to the rail section. Therefore, there is a need of transferring the load to a wider area so that that load remains within the capacity of load taking of those sections. So, this is another important aspect, that it should be able to transfer the load as a concentrated load which is coming from the rail track section to the ballast section. It should act as an elastic medium, that is, it should be able to absorb the blows or the vibrations which are coming from the rolling stocks movement over the rail sections. If it is not elastic in nature, then the deformation will keep on increasing, and finally the track will become irregular in shape, or there will be higher amount of settlement of certain locations. So, as soon as the load has been removed, it should come back to its normal condition. The longitudinal and lateral stability to the permanent way should also be there. This is another aspect. As we have seen in the case of rail sections, not only there has been the movements or the forces which are acting in the longitudinal direction, but there are other forces which are acting in the lateral direction too. And all those forces which are acting in either of the direction are going to be transferred finally to the sleepers. If the amount of these forces are quite large, then the sleepers will come out of their position and will be moving either along with the rail section, or they will just lose the strength which they are going to impart to the overall track structure. So, this is another aspect of stability. Both directional stability should be maintained. They should be means to rectify track geometry. We should be able, by just doing some exercises with the sleeper, we will be able to rectify the track geometry or the deformations which have distortions which have caused in the track geometry. So, based on all these functions which we have seen, now we are going to look at certain requirements. The very first requirement is always remains with respect to the cost. The cost, initial cost as well as the maintenance cost of the sleepers should be minimum. They should be moderate weight, they should be easy to handle. This is of course related to each other. If the weight is quite low, then obviously that is the easiest conditions as to handle the sleepers, but then in that case the stability or the stiffness of the track will not be there. Therefore, at least they should be of moderate weight or they should be of heavy weight, but at the same time the structure should be such that they are easier to handle. Fixing and removing of fastenings should also be easy. This is again related to the type of the material being used, at the same time the type of the design being used, so that if we have to remove or if we have to fix the fastenings, that should not be difficult job. Sufficient bearing area should be there to all the sleepers, so that they can transfer the load to a wider area of the ballast cushion. The maintenance should be easy and the gauge adjustment should be possible using the sleepers. Further, the track circuiting should also be possible. Now, slowly and slowly we are moving towards the electrified track conditions. Therefore, this is another important consideration and requirement of the sleepers. They should be able to resist shocks as well as the vibrations. If they are not in a position to resist shocks and vibrations, then obviously they will get crushed, and if they are going to get crushed, then the maintenance requirement will increase, the periodical maintenance will increase, then the cost will also increase. At the same time, they should be anti-sabotage type or anti-theft quality should be there. This is important as far as those locations are concerned which are remote or which are inaccessible or where the visual cannot be maintained throughout the time period. So, if they are anti-sabotage or anti-theft type, then the safety of the track will be maintained or the safety of the operations will also be maintained. Now, we have seen at the different types of requirements and the functions of the sleepers. Now, we are going to look at the types of the sleepers. The one type of the sleeper is the concrete sleeper. Now, these concrete sleepers have a very large life period. It is something like 50 years or even more than 50 years also nowadays. They lend strength and stability to the tracks because of their size, because of their weight. They maintain the gauge as well as the cross level and alignment in better form as compared to the other type of the sleepers, and this is again being governed by the structure, by the weight component of these type of the sleepers, because they are quite heavier in section. Therefore, they remain in position throughout, and that is how they are in a position to maintain the gauge, cross levels and alignment in a better way. And at the same time, they are also providing doing the circuiting of the track, and there are chances of less damage in the case of the concrete sleepers as compared to the other type of the sleepers. The other type of sleeper which has been in use from the very old time is the wooden sleeper, and this wooden sleeper most of the time it has the size of around 275 by 25 by 13 centimeters, and it has quite a low service life, and this life is somewhere around 15 years only. Another type of sleepers are steel sleepers. In this case again the life is comparable to the concrete sleepers, it is as high as 50 years. Then we have the CI, the cast iron sleepers. In this case one sort of a sleeper which is extensively in use is the CST9 sleeper, which is abbreviated as Central Standard Trial 9 sleeper. Now, we are starting with the different types of the sleepers. We will be starting with the older version of the sleepers, that is the wooden sleeper which have been in use. There are certain advantages of using a wooden sleeper. One thing is that they have been cheap in the older days, where there was a lot of wood available around, but nowadays we do not say that it is as cheap as it has been there relatively in the older years. They are easy to manufacture and they are easy to handle. This is one of the biggest advantage of using the wooden sleepers. They have also a good dampening effect because of the properties of the wood. This is coming that whatever shocks are coming or whatever vibrations are coming, they have the possibility or they have the chances that all these types of shocks will get dampened out because of the property of wood. Then they are also suitable for test circuiting because of again their nomenclature, because of the characteristics of the wood. They are suitable for yielding formations, bridges, ash pits, etc., which are provided with or without stone ballast. And the correction to the alignment is also easier in the case of wooden sleepers, because if at all the rails have to be displaced from their location at which they have been fixed to the wooden sleeper, that is easier to do because we can insert the fixtures or the fastenings at some other location easily as compared to other type of materials like concrete. But at the same time there are certain disadvantages too in the case of wooden sleepers. They are liable to mechanical wear. Whatever mechanical devices are used, they have all likelihood that they can penetrate the wooden sleeper, and when they penetrate the wooden sleeper, then this is the type of the wear which may happen to those wooden sleepers. They are having a shorter life period. This is due to decay, or this is due to the different types of the wears which can take place, or it is also due to the attack of the vermin. This is one type of the disadvantage which is not there in the other cases of the sleepers. Maintenance of gauge is a little difficult in this one because of the loosening effect of the fixtures or the fastenings which have been inserted in the wood. As the loads or as the vibrations keeps on coming, or as the impacts keeps of coming, these fixtures or the fastenings start becoming loosened out, and if they are getting loosened out, then it has its effect in terms of maintaining the gauge. They are susceptible to fire hazards, again one other characteristic of the material itself. They have the very less scrap value. This is one another aspect or disadvantage, because as soon as it has governed its completed its lifespan, so they will be taken out and some other sleepers will be provided, but at that time these sleepers which have been taken out, they are not going to pay back some amount in a handsome form. Further, we have sizes, as we have seen, the size is 275 by 25 by 13 centimeter cube. That is a normal conventional size of the wooden sleeper, but in the case of the bridges, the cross sectional area is increased by some amount, and here the depth of the sleeper is increased, and instead of 13 it may be 15 or 18. So, the cross sectional area will become 25 by 15 or 25 by 18. Then there are some categories of the wooden sleepers based on the type of the treatment to be provided or to not be provided. They are durable type of wooden sleepers. These wooden sleepers do not require any treatment, and they have a little higher service life as compared to the other type of sleepers, and they are designated as U type of wooden sleepers. The other one is non-durable type of sleeper, where the treatment is required before the placement, and obviously they have a shorter period of service life, which is around 12.5 years, and they are designated or indicated as T. So, T is for untreated and U is for untreated. So, T treated and untreated conditions respectively. Then in the case of the wooden sleepers, as the wood is being taken directly from any of the tree, and then as soon as it arrives, it has some amount of moisture. So, as in the case of the other wooden structures, a seasoning has to be done in the case of wooden sleeper. So, this seasoning is nothing but in this case it is treated such that the amount of moisture contained in the sleeper is reduced. So, moisture contained in sleeper to be treated by pressure treatment should not be more than 25%. and there are different ways available by which the seasoning of the wooden sleeper can be done. This is artificial seasoning in kiln, Bolton or boiling under vacuum process, air seasoning. This air seasoning is being adopted in India. There are different ways by which the air seasoning can be done, like 1 and 9 method, closed crib method or open crib method. In the case of this crib method, it is a form of the number of sleepers which have been placed at some distance from each other, and then there is another layer of sleepers which is placed at the top of this layer, but at perpendicular to the previous layer. So, this is how this crib method is used, and depending on the distance between the two sleepers, it is termed as the closed crib method or open crib method. Whereas, in the case of 1 and 9 method, it is sort of a jig-jag condition where one layer is being laid out, and then there is another layer which is starts from the same level at which the previous layer is being laid, but towards the other end where it is being laid at a perpendicular to the previous layer, there is another one sleeper being provided, so that the layer becomes tilted. So, that type of a method is termed as 1 and 9 method, and it has the flexibility of seasoning the wooden sleeper from all the sides, whereas in the previous cases they are not going to be seasoned from the bottom side where they are in contact with the other sleeper. So, that is an advantage of 1 and 9 method, and this is one method which is mostly in use in or adopted in India. Now, in the case of wooden sleepers, so as to look at the strength characteristics or determine the suitability of that particular timber for use, one index is found out, that is known as the composite sleeper index. In this case, it is a combination of the general strength at 12% moisture content designated as S, and H, that is the hardness value. This hardness value is taken again at 12% moisture content, and the formula is that CSI, that is composite sleeper index, is equals to S plus 10 H divided by 20. And the values of these composite sleeper index, they are different for different locations. In the case of the truck sleeper, this value is being prescribed minimum as 783, whereas for crossing sleepers it is being prescribed as 1352 as minimum again, and for bridge sleepers it is 1455. So, more strength is required towards the bridges sides or towards the crossing sides as compared to the normal condition of track. Now, coming to the another type of sleeper, that is the steel sleeper. This is one photograph of a steel sleeper which you must have seen, and this is the type of the sleepers which are provided like this. So, the shape goes this way and then again this way. This is a rail section which is placed at the top of this steel sleeper. Here this steel sleeper mostly in use is a steel through sleeper, which is nothing but a rolled steel plate 12 mm in thickness, and they are pressed to suitable through shape where the rail seat canted to 1 in 20 is provided. So, at this point there is a rail seat being provided at a this gradient of 1 in 20, and the ends are flattened down to retain ballast. So, what is being done is that this end of this sleeper is being made like this. Now, the advantage of doing this is that whatever ballast section is being placed at this level will not go out as soon as the loads are transferred from the top. So, this is how it will contain the ballast below the sleeper. So, this is the way by which it is done. This is another diagram where the overall section of the steel trough sleeper is being shown. This is like a wavy section where the rail is being placed one here and the rail is being placed here, and as being told that there is a cant of 1 in 20 being provided at this side. Similarly, there is a cant of 1 in 20 being provided at this location, and this is the gauge of this track. So, this is the steel trough sleeper. This is another photograph where it is being shown that there is this steel sleeper, and this steel sleeper is being jointed to this rail section using certain fastenings. These are the types of the jaws which have been provided here, by which This is a clamp using these jaws and the clamps. This rail section is kept in place on these steel trough sleepers. So, we have two types of cases in this one. One is the steel trough sleepers with pressed out lugs, other one is the steel trough sleepers with loose jaws. In the case of these two, we are looking at this one. This is pressed lug out lugs, a steel trough sleeper, where this is a steel sleeper in which a grooving is being made like this. So, this metal is coming out in this direction, whereas this metal is coming out in this direction, and this is termed as pressed up lug. Within this area, a rail is being seated, and then it is fitted to its position using the keys at this position as well as the keys at this position. So, they have sufficient strength so as to keep this rail section into position. At the same time, whatever cant is to be provided as 1 in 20 is being maintained at this bottom level. This is another case where the loose jaw condition is shown. This is a loose jaw being provided here as well as here, and again this rail section is being placed and being held up by using the keys between the rail section and the loose jaws. So, this is another type of the steel trough sleeper. Now, some of the advantages of a steel trough sleeper: they are having a longer life, they are better in the lateral rigidity, they are free from decay and fire hazards. This is a metal property. They have good scrap value, again a metal property, because in the case of wooden sleeper, as we have seen, they do not have any scrap value. So, even if they have completed their life, they are going to provide some monetary value. There are lesser damages during handling and transportation. This is again metal characteristics only with as compared to the wooden sleepers, as we have seen previously, where the chances of damage are much more as compared to this one. And based on all these things, there is a less maintenance problem in the case of the steel sleepers. So, and they are also easy to maintain gauge, but there are some disadvantages too. We will look at these disadvantages. The very first one is that they are liable to corrosion. Previously, we have seen that there are certain locations like the coastal areas or tunnel areas, or the locations where some of the industries have been provided, where the effluents are coming which have a corrosive nature. So, if we are providing the steel sleepers or those locations, then they are liable to get corroded, and if they are getting liable to, if they are getting corroded, then the lifespan will get reduced. They are unsuitable to track circuiting because of the chances of related to the electric currents being passed into the metal. They become center bound due to sloping ends. We have seen in the case of the sleepers, there are two type of conditions as far as the deflections are concerned. One is the center bound sleeper, and the one is the end bound sleeper. In the case of the center bound sleeper, because of the sloping ends, what happens is there are chances of more of deflections taking place at the central locations as compared to the end locations. And of course, they are also rail specific. As we have seen in the case of the rail, there are three types of the rails: double headed rails, bull headed rails, and flat footed rails. So, depending on the type of the rail section we are using, there are certain fastenings which needs to be used. So, it is not that whatever is the grooving being made in the steel through sleeper, we can seat any of the rail structure in that one. So, the rail structure is to be used along with some fastenings which are specific to rail as well as the steel trough sleeper. There are tendencies of developing the cracks at the rail seat. This is the weakest point in this structure, because the sleeper itself is of sheet type. It is 12 mm in thickness. That is why, and further as we have made a grooving in that one. So, this becomes a weakest joint, and this is the reason why there can be the development of cracks at this location. Now, we come to the other category of sleepers. This other category of sleepers is CI sleeper or cast iron sleeper. In this case, we have again different type, that is one is a CI pot sleeper. This CI pot sleeper is not suitable for curves sharper than 4 degrees. This is one case as far as its use is concerned. Then another thing is that the fittings are hidden and therefore, the maintenance becomes difficult. So, if we have to change any of the fitting, then the first of all the pot sleeper has to be removed and then only those fittings can be changed. So, that is one of the biggest disadvantage in using the CI pot sleepers. This is one of the diagram of a pot sleeper, where this is the rail section being shown here, and this is inverted pot being placed at the ballast cushion. So, this is a ballast cushion. So, this is a pot being placed like this one. So, one thing which may happen is that the ballast will go inside the sleeper. So, there is a sort of a packing of ballast within this sleeper. But another aspect is that this sleeper is to be connected to the another sleeper on the other side. So, this section which is being shown here, it comes out on this side like this one, this is a bar. So, this connecting bar will go to the other sleeper and this is how they are going to be connected. This is one thing. Another thing is that this sleeper has to be connected to the rail sections using different fixtures as being shown like this here, and they are finally going to be connected somewhere inside. That is the reason why the maintenance is a little difficult in this type of a sleeper. This is another diagram of a CI sleeper, where the further details have been shown. What we can see is this is an inverted pot like this, and then this is a place where the rail is being seated. So, this is a chair of the rail being provided, and so as to keep this rail section into place, again the keys have to be used. So, we are using this key so as to keep it in place with a cup. So, key and cup arrangement is there, whereas at this location it is being held up like this one. So, this is a section of the rail which is being provided. It is trying to maintain some pressure at the foot of the rail section. Then here we have this tie bar. This tie bar is going from this one sleeper to the another sleeper on the other side of the gauge, and obviously this is being connected with the pot and the other fixtures by using jib at this location or at this location too. So, the another type of CI sleeper is CST9 sleeper. CST9 sleeper is the name which comes from Central Standard Trial Sleeper. This name is coming from the different number of tests which have been carried out in the laboratories of the railways, where they have tried different type of sections or different type of designs related to the cast iron sleepers. So, in this section, this is the 9th trial which has been you can say a successful trial, and further after this 9th trial, again some more trials are going on like 11, 12, 13 and likewise, but still at most of the sections we are using this CST9 sleeper. Now, this CST9 sleeper is sort of a combination of pot sleeper, plate and the box type of a sleeper. So, all the things have been mixed together so as to form this type of sleeper, that is CST9 sleeper. They can be termed as the triangular inverted pots. The central plate is provided with the projected keel, and there is a box which is provided on top of the plate. So, this is what is the combination of the three things which are used in the formation of CST9 sleeper. Then it has a tendency of reducing the rocking of the sleeper under the rail wave motion. Now, as we have seen that there are so many fixtures which have been used, it is a sort of a little complicated design which has been used. So, it helps in reducing the rocking behavior of the sleeper because of the moving rolling stock. And one advantageous condition with the CST9 sleepers, or basically the CST sleepers, is that they have a wider area through which the loads can be transferred from the rail sections to the ballast cushion sections at the bottom, and the bearing area is approximately of the same structure as being provided for the wooden sleeper. So, this is one of the biggest advantage in the case of the CST9 sleeper. Further, in this case of CST9 sleeper, they are not suitable for mechanical maintenance with tie tempers. This is again because of its design, because of the different types of the fastenings or fixtures which have been used. That is why the mechanical maintenance cannot be done, where the tie tempers are used in the mechanical maintenance. They are mechanical devices, they are automatic sort of devices, and they can do the maintenance by itself, but then in the case of the CST9 it is not possible. Then they causes early wearing of the rail seat. This is one of the disadvantages of CST9 sleepers. The use of breathing lens in LWR is problematic. This is another problem related with the use of CST9 sleepers, and the loosening of ballast due to transmission of shocks directly. Now, in the case of the previous one, where we have seen that they are having a turning at the ends, and that is why they will be in a position to retain the ballast section where it is. A sort of a locking of the ballast section was possible, but in these cases there is a loosening of ballast because of the loads, and this ballast may go out, and therefore, the periodical packing of a ballast section is to be done. This is one of the diagram of CST9 sleeper. In this case, what we see is there is an inverted triangular plate which is being used. Then there is a flat plate condition which is used here, and a sort of a cup being placed on this side. So, this is elevation of the CST9 sleeper. In this one, the rail section is being placed here. So, the grooving is being made, and we are using a two-way key which is inserted at this location, so that this rail section can be placed and maintained and hold out at its level. And then in this case again we are using the tie bars, and these tie bars are jointed to this triangular plates by using cotters at this location or at this location. So, these are the type of the sleepers which have been used, and probably you have also seen these type of sleepers being provided. There is a very thin bar which is used so as to connect this sleeper with the other sleeper on other side of the railway track, that is based on the gauge. This is the plan of the same one, and here this is the rail section being placed, and this is a key being inserted in this one, and this is how we find the shape of this. This is inverted condition being here. So, this is a slanting going down in this direction and slanting going down in this direction. So, the box type of a structure is being placed in this one, the triangular structure is being placed in this one, and the plate structure is placed on the other side. So, this is a combination of different things, and then at the bottom of this one there is a keel being provided. The idea behind this is that it tries to maintain, because it gets inserted into the ballast cushion. So, this is how it will remain into its position at that ballast cushion level. So, this is what is the diagram of CST9. So, now we look at some of the advantages of the CI sleepers. In the case of the CI sleepers, they are less corrosion prone as compared to the steel sleepers. They are less liable to crack at the rail seat, because the strength of these sleepers have been increased by using different type of fittings, that is triangular shape or box shape structures which have been used in the construction of this sleeper, and then they are easy to manufacture. They have a higher scrap value as compared to the other type of sleepers, but there are some disadvantages. The disadvantages are that there is a difficulty in the maintenance of a gauge. There is lesser lateral stability in these type of sleepers. and they are unsuitable for track circuiting, as we have seen in the case of steel sleepers too, and they are also unsuitable for mechanical maintenances, because the space being provided or the type of the design which is being used in the formation of these sleepers is so complex that it is not possible. They are susceptible to breakages at those locations where the different type of structures have been combined with each other, that is the plate or triangular or box structure which has been combined together. Now, we come to the another category of sleepers. These are the concrete sleepers. In the case of concrete sleepers, we have different type of loading conditions. So, we will be looking at first of all for what design these concrete sleepers are being taken up. The loading conditions remains like they should have the vertical load at the rail seat equivalent to 15 tons. So, they are going to be designed for 15 ton vertical load at the rail seat level. This is the load. Then another category, another condition which needs to be satisfied is that this 15 tons load along with the reaction at the center of the sleeper, which is equivalent to the intensity of half of the load that is there under the rail seat, is to be considered. So, that is another condition, another loading condition which is to be considered, and the third condition is that this vertical load is reduced to 13 tons, whereas the lateral load is taken as 7 tons. So, this is another combination of the loading, vertical load with the lateral load. And the final loading condition is of the bending moment, where the bending moment is taken as 1.33 ton meters at the rail seat and is taken as 0.52 ton meters at the center of the section. So, these are the 4 conditions for which the concrete sleepers have to be examined or tested, and once they comes out satisfactory under these testing conditions for these different loading conditions, then they are used in the track. So, this is one aspect related to the design of the concrete sleepers. Another aspect, another factor which needs to be taken into consideration as far as the design is now on the basis of this we can see is that the forces which are acting on any of the section or any of the sleeper, the various forces as we see in the loading conditions are vertical loads or the lateral loads or the type of the bending moments which will be there. There is also an effect of geometrical form or the shape of the sleeper. This is to be taken in the form of what is the overall shape, what is the size, and then what is the weight of that sleeper. Obviously, the shape or the size they are going to govern especially the bending moment, because the point at which the lateral load is acting or the point at which the vertical load is acting, then if we go for the calculation of the bending moment maybe at the rail seat or at the other location, then the distance will come into consideration. So, that is why the geometrical forms have their effect. And then this weight is another aspect, because this weight is going to add on to the vertical loads which will be coming from the rail seat. And this weight is not only it is going to create a resistance to the vertical loads, because if it is going to be increased then it will be having the more of stresses or resistances offered to those loading conditions. Then characteristics of fastenings which are provided between the sleeper and the rail section. So, what type of fastenings have been provided, whether they are the conventional type of the fastenings being used or they are the elastic fastenings being used. These are the two types of the fastenings which are generally used in the permanent phase. So, we have to look at what fastenings we are using. Mostly in the case of concrete sleepers we use elastic fastenings, and a provision of failure against derailment, because if there is a derailment then obviously it is going to just damage the concrete sleepers, and therefore, in that condition the only remedy is to just renew the sleeper. Therefore, what are the provisions which have taken against derailment or against failure of such type? That is another important aspect which is to be taken into consideration while designing the concrete sleepers. Now, there are some of the advantages of concrete sleepers. They are the being heavy, they lend strength and stability to the track. They are suitable for LWR due to resistance to buckling, because they are quite heavy. So, that is why they are able to provide those resistances. They maintain the gauge alignment and the cross levels. As we have seen, this is again coming because of their heaviness or because of the weight of the concrete sleepers. The track circuiting is possible in this case as in the case of the wooden sleepers, whereas in the previous two cases, that is the steel sleepers and the CI sleepers, it was not possible. The corrosion or the damage due to pests or the fire hazards, all these three conditions are not there in the case of concrete sleepers. They are not going to be affected by the corrosive conditions, they are not going to be affected by the fire hazards and by the pests. They have a longest lifespan, even more than 50 years. The better mechanical maintenance is possible in the case of the concrete sleepers as compared to the previous sleepers, because of the easiness of the design of the concrete sleepers. And the local resources can be used for making of forming the concrete sleepers. That is another advantage. Whereas, in the rest of the cases, what is to be done is that they are rolled out sections, or they are the sections which have been made in the workshops. So, those have to be done there and then they are taken to the sites. At the same time, some disadvantages are also there. One thing is, because of their heavy weight, the handling and laying is difficult. Heavy damages are there in case there is a derailment. Because of again the material property, the concrete is of such thing that if it gets removed, then it loses the strength. So, if there is any derailment and damage is being caused, then the whole of the concrete sleeper has to be removed and replaced. There is no scrap value again in this case, as being seen in the wooden sleepers condition 2, whereas in the previous two conditions we were getting a bigger higher scrap value. They are not suitable for beater packing. Beater packing is again a sort of a mechanical devices where we have to beat the ballast cushion which are being provided on the sides of the sleepers. So, that is what is the packing of the ballast is there. So, it is not suitable for that, because of a chance that if this beater is hitting the sleeper, concrete sleeper, then the concrete sleeper may get damaged. The cost increases due to use of mechanical handling procedures. So, this is another disadvantage in the case of concrete sleepers, though the mechanical handling is possible, but then it is increasing the cost. We have seen because of the heavy loads or heavy weights of these type of sleepers, we cannot do it manually or using the manual labor. This is one type of the sleeper which is being shown in this diagram, or this is another type of the sleeper. We are looking at these two type of the sleepers, that is the mono block sleepers or the twin block sleepers condition. This is one track where the mono block sleeper is being provided. What we found is that this is the sleeper comes like this, then the section is being reduced at this point. Here the section is more thicker, where at this location the section is less thicker. The reason behind is that whatever loads are coming, they are going to be dispersed through the area, certain area in this section. So, we have taken some distance up to this point and some distance up to this point, after which the section has been reduced in this one, and this is again is increased as we come toward the other rail section. So, this is a mono block concrete sleeper. They are trapezoidal in section. The cant of 1 in 20 is being provided for 175 mm from center line of the rail, and initial pre-stressing is done at a value of 65 tons per square inch. That is already they are being pre-stressed. The stressing is being done before they are laying. So, this is the amount by which it is being done, and they have a crushing strength at the end of 28 days as 525 kg per square centimeters. and pandural clips are provided so as to join the rail section with the concrete sleeper. So, here at all these locations whatever we are seeing, they are the fixtures, they are the fastenings which have been used so as to join this rail section with the concrete sleeper, and generally this fastening is the pandural clip which is being used. And this diagram what we are seeing is in this photograph, what this is a twin block RCC concrete sleepers. Here this is again the section being shown like this. This is the depth of the concrete section below the rail seat, and this is how it is being reduced so as to seat the rail section here, and then it is being jointed on both the sides by using some fixtures which has been shown here or here or here. And in this case again, because two blocks have been used, one below this rail section and another below this rail section, they have been jointed together using the bars. So, we have the tie bars which have been used here like this, they are the tie bars which have been placed at here this level. Now, there are certain locations in which the concrete sleepers should not be used. One is the new troublesome formations. The concrete sleepers should not be used unless until they have stabilized. It is a sort of a condition which we have seen in the case of LWR or CWRs. The rock cuttings without ballast cushion, that is another area where if there are the rock cuttings are being provided and the track is directly being laid on those rock cuttings, then in that case the concrete sleeper should not be used. If they have to be used, then the ballast will also be used. Then unballasted lines in yards, again in those conditions the concrete sleeper should not be used. Curves of radius less than 500 meters, whatever we are seeing, this is another condition which we have seen in the case of LWR, where the LWRs are also prohibited. Then locations of excessive corrosions, there are the conditions if the reinforced sleepers have been used and the twin block sleepers have been used, where the two sleepers have been connected using the tie bars. Unballasted or R shaped or the slab bridges are there, then in those locations also they are not to be used. Or in those conditions where the fish plated tracks are used. So, instead of this, if the welded joints are being used, then we can go for the concrete sleepers. Now, we come to a sort of a comparison or the points of comparison between the different types of the sleepers which so far we have discussed. What we have discussed is on the basis of the cost per sleeper, the cost is going to be lower in the previous cases as compared to the concrete sleepers. The life is highest in the case of concrete sleepers as compared to the other sleepers. The weight per sleeper is to be examined, and this is much higher in the case of the concrete sleepers as compared to the wooden or CI or the steel sleepers, the ratio being something like around 1:4. Then maintenance cost is lower in the case of concrete sleepers compared to the other sleepers because of the chances of decays or corrosions or wears being less. Handling is easier both in the case of the wooden sleepers as well as in the case of the steel sleepers, but in the rest of the cases it is a little difficult. In the case of the concrete sleepers, because of the heavy load, it is more difficult. Track fittings, more track fittings are required in the cases where the steel sleepers or the CI sleepers are being used. In the wooden sleepers, simple fittings are being used, whereas in the case of the concrete sleepers, we already insert the fittings while the manufacturing is being done of those one, or the grooves as required so as to fit in are provided. So, normal fittings will be required, but one thing is there in this case is that the fittings in the case of the concrete sleepers, they are elastic in nature, whereas in the case of wooden or steel sleepers, they are both may be elastic or conventional in nature. Elasticity of the track is another point where the comparison can be made. Then another point is the laying and relaying of the different components of the track along with the sleepers, that whether it is possible to lay and relay the sleepers easily or not. In the case of the wooden or the concrete sleepers, looks a little easier as compared to the other one. Than the rigidity of the track, it is more rigid in the case of concrete sleepers as compared to the other one. Suitability of the track is another aspect needs to be looked at, that is what are the locations where these type of sleepers can be used. We have already seen in the case of advantages, disadvantages of the different sleepers when we have discussed them. The suitability aspect has also been taken care of. Track circuiting is possible in wooden and the concrete sleepers, but in the other two cases it is not possible. Gauge adjustment again is much better in the case of concrete sleepers. Now, we look at another aspect related to sleepers, that is sleeper density. The sleeper density is defined as number of sleepers per rail length, and the mathematical abbreviation for this one is defined as m plus x, where m is the rail length and x is the number which varies from 4 to 7. So, if we have a rail length as 13 meters, then 13, and if we take the number as 4, then 13 plus 4 means 17. It means there are 17 sleepers to be provided below 13 meter length of the rail section. So, this is what is the sleeper density for that case. Then this sleeper density depends on certain factors. The factors are the axial load. If the axial load is increasing, the sleeper density should also increase. If there is a higher speed, then we require to just resist the augmented conditions of the different loads which are coming. So, therefore, again the sleeper density needs to be increased in this case. If the lower rail sections are being provided, the sleeper density can be increased again, but if the higher sections are there, then the sleeper density may reduce. Then the type of the sleeper which is being provided, if heavy sleepers have been used, then the sleeper density can be reduced too. What is the thickness or the depth of the ballast cushion, or what is the type of the ballast being used, that is another factor which may define the sleeper density or the number of sleepers which should be provided, because it is going to depend on the load taking capacity of that ballast. Similar is the case for the formation level, because formation level is the final level up to which the loads are going to transfer. So, if it is weaker in section than in taking the load, then more of the sleepers needs to be provided at the top of the ballast cushion. Now, the next point or next aspect related to sleepers is the spacing of sleepers. Now, the sleepers are defined in different forms as we see in this diagram. This is the rail section, this is another rail section, and the joint is being provided at this point. Any sleeper which is provided just adjacent to this joint at this side or at this side, this is known as joint sleeper. Whereas, any sleeper after this one, that is the first sleeper which is provided after this one, is known as first shoulder sleeper. Then the next sleeper which is provided is known as second shoulder sleeper. Any sleeper provided after the second shoulder sleeper is termed as intermediate sleeper. So, this is how the sleepers are designated, and then in this case whatever is the distance available between these sleepers are designated as A, B, C and D respectively. So, we have to look at the values of these A, B, C and D. In the case of this is a case of the fish plated track. So, in this case what we see is that the spacing of sleeper is being defined here for two cases, that is wooden and metal. In the case of between joint sleepers, that is distance A, it is given as 30 centimeters for wooden and 38 centimeters for metal. Then between joint sleeper and first shoulder sleeper, it is 61 centimeters in both the cases. Between first shoulder sleeper and second shoulder sleeper, it is 70 or 72 centimeters if the sleeper density is m plus 4, and it is 64 or 63 if the sleeper density is m plus 7. In the between the intermediate sleepers, this is 84 or 83 if the sleeper density is m plus 4, whereas it is 68 centimeter if the sleeper density is m plus 7. Similarly, in the case of the welded track, that value is defined in terms of 1660 sleepers per kilometer length, and the spacing is 60 centimeters in this LWR section. If it is 1540 sleepers per kilometer, then the spacing is 65 centimeters in LWR and 66 centimeters in SWR. And if it is 1310, then the spacing is 78 centimeters in SWR condition. So, what we have discussed today is the different aspects related to sleepers, their functions, their requirements, the different types of the sleepers, their advantages and disadvantages or their comparison, and finally, the sleeper density and the sleeper spacing. All these things are the part of the design features of a permanent V. This is one of the another component which we have discussed today in this lecture, and we stop at this point and I say goodbye to you. Thank you.